Our next unit is called stoichiometry. Kind of hard to pronounce, but pretty easy to do. Okay, stoichiometry deals with things like, let's say I want to produce eight, let's say cakes. Okay, I'm a cake maker and I like to make cakes, so I'm going to make 8 cakes. And for every 8 cakes that I make, I need 3. I'm going to change this a little bit. We're only going to make 3 cakes. Okay, we're going to make 3 cakes, and for every 3 cakes I make, I need 8 eggs. Okay, so I need 8 eggs for every 3 cakes that I make. Okay, let's say I want to make 45 cakes. Okay, I'm going to make 45 cakes all total, and the question is, of course, how many eggs do I need for that? Okay, well, here's what we might call our balanced equation. To make 3 cakes, I need 8 eggs. So if I want to make 45 cakes, how could I mathematically do this? Well, I've got cakes up here, so I'm going to put cakes on the bottom. 3 cakes, and then whatever 3 cakes are equal to are going to go on the top. Just like all the other problems that we've done before, 8 eggs. And notice that my cakes are going to cancel. And so now what I'm doing is I'm figuring out how many eggs I need if I want to make 45 cakes. Okay? So I'm going to take 45 times 8, which is equal to 360. 360 divided by 3 equals 120 eggs. So if I want to make 45 of my cakes, I need to go to the store and I need to buy 10 dozen or 120 eggs. Okay? And this step right here where we converted from cakes to eggs, that is basically what stoichiometry is. It's a mathematical comparison of the amount of the reactants to the amount of the products in a chemical reaction. Okay? And so now let's go away from cakes and eggs and let's look at a real chemistry example. So how do you perform calculations using stoichiometry in chemistry? Is we use the balanced equation. Just like I used my quote-unquote balanced equation up here. 8 eggs makes 3 cakes. Same thing here. We can say that 3 moles of calcium hydroxide will react with 2 moles of H3PO4, which will produce 1 mole of calcium phosphate and 6 moles of water. Now, we don't really care too much about any of this stuff other than the things that they ask us about. So, for example, 5.24 moles of calcium hydroxide is kind of like saying 45 cakes. That's the amount that you're starting with. So we're starting with 5.24 moles of calcium hydroxide, which is this one right here. Okay, and then they want to know that's going to produce how many moles of calcium phosphate, which is here. So we're going from calcium hydroxide to calcium phosphate. So notice how I do this and how it looks really, really similar to the problem that I did up here when I converted my 45 cakes to eggs using, again, here's my balanced equation. So to use my balanced equation, I'm going to go from cakes to eggs. Here I'm going to go from moles of calcium hydroxide to moles of calcium phosphate. So I start with what they give me, the 5.24 moles. Just like up here, I started with the 45 cakes. And then what did I put on the bottom? Whatever's right here, just like up here, since I had cakes here, I had to put cakes on the bottom. So I put moles of calcium hydroxide on the bottom, and then I use the coefficient from the balanced equation to go right there. That's 3 moles of calcium hydroxide is going to make, now let's come over here to what they're asking us about. Remember, they're asking us about eggs up there. Now they're asking us about calcium phosphate. And again, what's the coefficient? What's the number in front of calcium phosphate? It's a 1. So what this balanced equation tells us is, again, that 3 moles of calcium hydroxide make 1 mole of calcium phosphate. And so we can see that here, that 3 moles of calcium hydroxide are going to make 1 mole of calcium phosphate. And then what do? We take 5.24, we multiply by 1, we divide by 3, and we get an answer of 1.75. Now notice, like those conversions we did in Chemistry 1, the moles of calcium hydroxide here have to cancel. So those must go on the bottom of the fraction, and that's how we knew that moles of CaOH2 have to go down here, because those and those cancel. Just like up here, our cakes and our cakes canceled, and we were left with eggs. We want to be left with whatever they're asking us about, which is our moles of calcium phosphate. Okay, and then again, we multiplied the number on the top, we divided the number on the bottom, and we got our answer. Okay, let's look at example number 2. How many moles of HCl are needed to react with 0.128 moles of magnesium? So again, just like the previous example, we start with the number that they give us, 0.128 moles of magnesium. And now, again, we want to cancel the moles of magnesium. So I put that on the bottom, and I put moles of whatever they're asking me about on the top. So I have moles of HCl on the top. And then where do that 1 and that 2 come from? Of course, from the balanced equation. Notice that you're starting with 1 mole of magnesium, and it's going to react with 2 moles of HCl. So 1 mole of magnesium, 2 moles of HCl, and then in my calculator I take 1.128, I multiply by 2, I divide by 1, and I get an answer of 0.256 moles of HCl. Okay, one more and then we'll be done with this video. So in example 3, it says Na reacts with H2O to make NaOH and H2. First of all, it says balance the equation. So let's stop right there and let's go ahead and do that. 1 sodium, 1 sodium, 2 hydrogens. Here's 1 plus 2 more is 3 hydrogens. So I'm going to put a 2 right there. Now that makes 4 hydrogens. So if I put a 2 there, that's going to make 5. I don't want 5. I want to try to see if I can get 4. So I'm going to put a 2 right there. Now that makes 2 hydrogens plus 2 more. There's our 4 hydrogens. So we've got 4 hydrogens. Now I think we messed up our sodiums though, didn't we? We have 2 NAs, so I need a 2 there. And then for oxygen, I have 2 O's, and then I have 2 O's. So it is now a balanced equation. 2 Na atoms react with 2 water molecules. Oops, I erased that 2 there. To make 2 NaOHs plus H2. And then it says, calculate the moles of H2 produced from 6.43 moles of Na. Okay, and really, again, that's all stoichiometry is you're converting from the moles of one thing to the moles of something else. Using the moles from the balanced equation to convert from the moles of one substance to the moles of another. So we're going to start with what they give us. And this is a good point for you to pause the video. Go ahead and give this a try yourself. See if you can do it. And then come back and see if your answer matches mine. So I'm going to take 6.43 moles of Na. And then I know I need to cancel moles of sodium. So I'm going to put moles of Na on the bottom. And then from the balanced equation right here, I can see that there's a 2 that goes there. And then what goes on top? What are they asking me about? They're asking me about moles of hydrogen. So I'm going to put moles of H2 on the top. And then I again come to my balanced equation. Notice there is no number in front of the H2, which means that is a 1. And now it is set up correctly. And again, guys, that right there, that step right there, that is the stoichiometry step. Okay, that's the step where you're converting from the moles of one substance to the moles of another one using the coefficients from the balanced equation. That's all that stoichiometry is using that balanced equation to convert from moles of one thing to moles of something else. So now I take 6.43, I multiply by 1, I divide by 2, 6.43 times 1 divided by 2 equals, and that has 3 digits, so in my answer I'm going to put 3 digits, 3.22 moles of H2, and that is the correct response. Okay? So in all three examples that we've seen, we're using the balanced equation, and we're saying that, for example, back here in example 2, 1 mole of magnesium reacts with 2 moles of hydrochloric acid, making 1 mole of hydrogen gas and 1 mole of MgCl2, magnesium chloride. Okay, back here in example 1, same idea. 3 moles of calcium hydroxide react with 2 moles of phosphoric acid, making 1 mole of calcium phosphate and 6 moles of water. So we can jump from one thing to another. For example, here we went from moles of calcium hydroxide to moles of calcium phosphate. I mean, what if I said you have 12.7 moles of H3PO4, and I wanted to know how many moles of water that made? Well, it's the same process. We would take 12.7 moles of H3PO4, and then on the bottom I would put 2 moles of H3PO4, and I'm asking you about moles of water, so on the top I would put 6 moles of water, because that's exactly what happens in this chemical equation. 2 moles of phosphoric acid makes 6 moles of water, and that's what we're representing there. So we would there take 12.7, multiply by 6, divide by 2, cancel our moles of H3PO4. 12.7 times 6 divided by 2 equals 38.1, I believe. So that would be 38.1 moles of water would be produced.